How did clean code change your outlook on software engineering?
That's not what professors are teaching you. They're just teaching you how to just get through the basics of programming.
What if that snowballing happens not with another engineer, but with, let's say, a product owner?
Hey, welcome to Dev Better. Today we're going to talk about Clean Code, the book by Uncle Bob. Again, controversial guy. Let's leave that over there. And talk specifically about his book and how it impacted our perception of software engineering. There's a lot of really good ideas in the book itself, and we want to dig into that. We're going to start today by just generally giving an overview of what the book is designed to help us understand as software engineers. And with me, I have my favorite engineering crew. Don't tell the rest of my team I said that. Jeremy Wood and Maharshi. No need to introduce yourselves. By this time, people should know who you guys are. You're kind of my regular coding crew. So let's just jump straight in. Let's talk about the book just from a thought leadership perspective. I read Clean Code a long time ago. I don't even remember. I'm not going to try and remember the specific dates, but it was a very good book for me at that season of my career. It helped me understand some of the things that I was struggling and wrestling with, like this concept of clean code with respect to naming, small functions, the things that the test-driven development crowd tends to just bake into what they do every day. And by the way, I am a fan of TDD. I think it's a great way to build software. But this book was great for helping me to understand some of these concepts that generally people weren't talking about when I was a journeyman software engineer at Microsoft and the other places that I've been in my life. So first, let's define kind of what clean code is, and I'm going to go around the room. I'd love to hear Maharshi and Jeremy's opinion on this, but I'll go first. For me, the definition of clean code is code that reads top to bottom, left to right like a book. It clearly maps the ideas that it's trying to convey and the business problem that it's trying to solve, preferably with tests that are functional based and not just tests that are there for the sake of coverage, but things that prove out certain ideas and certain requirements that we're trying to solve for, and code that is maintainable, which again, this is a ton of subjectivity. We're going to talk about some of that as we go, but I know that the concept of clean code is very difficult to scientifically answer. So let's go through the crew. Jeremy, you start, then Maharshi. What is your definition of clean code?
Well, you really took a lot of the words that I would use. It's easy to read. Readability is very high. Like you said, reads like a book, because that's a big factor in creating maintainable software. You're reading code maybe 90% of the time, so it needs to read well. And that's what clean code is code that reads well.
Maharshi, what do you think?
Yeah, I mean, like Jay Wood said, y'all took the words out of my mouth. But for me, coding is also a part of building a community. If you're a part of a company, there's a high likelihood you're not writing code on your own. So clean code brings into the aspect of, if I'm bringing somebody else onto something I'm working, how fast can I ramp them on?
By the end of this, I would like for us to decide if the Quake fast square root is clean code, which will be kind of a fun exercise. We can pull it up at the end and talk about it a bit, but there's a lot of things about that function that I think are clean, and there are other things that are like, what the hell is going on? So I think it's just a fun example to maybe talk about at the end. So great. So let's talk about how clean code changed your outlook on software engineering. For me, it was, again, a seminal work that helped me understand a lot of the things that I was doing that felt wrong, but I did anyway. This idea of code smells, which was a Martin Fowler, I think Martin Fowler coined this term early on, and that also fed into the clean code work. So let's go around the room and talk. Maharshi, let's start with you. How did clean code change your outlook on software engineering?
Going into my first job, I started reading a little bit of clean code. And when I was doing like my very first piece of actual work, rather than just writing out tests, I kept remembering certain phrases from the book, and I would use those to implement. And I thought, like, one of those examples is make sure that your code is readable by just a random third party. Just bring them in, see if they understand what you wrote. And that's something that I've stuck by. And so coming into 7-Factor and working with other clients, trying to do that has helped a ton, especially, if I'm switching teams. So yeah.
And also just from a communications perspective, you're hitting on, and then we'll go to you, Jeremy, one of the key pieces that I feel very strongly about, and that's communication inside teams has to be seamless, understandable, easy. That we talk about speaking the same domain language, and I love that actual idea that let's go find a product owner and have them read our code. I mean, some product owners will probably say no, I don't want to see any of that. But honestly, if a product owner can read your code and say, oh, I get what's going on because the owner wrote the story and they understand the feature, they're like, oh yeah, I couldn't have done that, but I get what's going on. I would call that a massive win for you as a software engineer, right? So what do you think, Jeremy?
I think that Clean Code was one of the books that I felt really leveled up my coding abilities. There's one other, but it's funny. I read that first, that was Effective Java. And then Clean Code almost like refined a lot of what I learned in that book, and helped me to just write better code. And, I was focused a lot on writing kind of library code. And so, that's code that a lot of people are intended to use. So writing it clean was really important to me. And so I felt like this book was just like exactly what I needed at the time.
Effective Java is a fantastic book. I don't want to dig into that one. We could spend probably weeks, and there are people that are likely way smarter than me that could help drive conversations around that book. It taught me everything I needed to know about concurrency. It was a fantastic, I consider it, again, Josh Block, a seminal book. If you're a Java developer and you've not read this book, you need to go buy it right now. And no, I don't get any kickbacks for that. But I agree, it was a fantastic book. And Clean Code is a good revision on top of the very technical ideas that you learn in that particular arena. Let's talk about code that isn't so clean, right? I think that clean code is a subjective idea, but this book is great at laying out through each chapter basic ideas that I think we all can get on board with. Why do you all think that unclean code exists? Jeremy Wood.
Well, that's a interesting question. I think that a big part of it is that people learn to program in ways that just don't teach that. Like going through, if they go to university, that's not what professors are teaching you. They're just teaching you how to just get through the basics of programming. And not to mention that a lot of them are researchers and not career programmers. They don't end up having to work with a lot of other people with their code and have to deal with the maintenance of the code. Cause if they're doing research, like maybe it's a function to, I don't know, calculate something about nature, and that's not, I don't know, it may not be as important. That's kind of debatable. But that's one factor. And then also the people who learn on their own, if they're taking tutorials on YouTube, like if those people never learned how to write clean code, then they're not going to be teaching clean code, or just what they are teaching is not that. They're teaching you the basics again. And I mean, that's what a lot of people struggle with, is like learning basic logic and operators and all of these things that are definitely important to learn, but they're not clean code. It's like that doesn't even come into the equation.
Right. On one of the previous episodes, we looked at some code that I wrote called WinBERT, which I think we looked at the app domain toolkit on GitHub, and I wrote that for a professor for a master's level project, and he told me, this is the best code I've ever seen. And I was like, seriously? I was not well versed in the ways of grad students, and again, no shade at grad students, because you're there to prove out a theory, like you said, Jeremy. You're there to add to the academic pool of knowledge, right, that's out there. You're not there to write the most clean, amazing, efficient, ridiculous code that looks beautiful that you can put on the internet. And one of the things that I was into when I was doing this master's degree was clean code. And you can see that I tried really hard and failed in many ways, but I tried really hard to be super clean about how I wrote the tests and how I built that for that professor. And I was very shocked when he came back to me and said, this is like the best code I've ever seen, because I certainly didn't think that at all. What do you think, Maharshi?
I think one of the main reasons is just because people are just never taught to write good or clean code. Um, I mean, all through college, I was just like, so long as the code works, I'm safe. I mean, there was a project where we were supposed to use AI, and I procrastinated on it so hard, I hard coded what the AI was supposed to do and passed it off as, "Hey, it's working." Um, and going into to my first job, I was like, "Oh, this strategy will work out great, right? If my code is unreadable, if my code is gross, it's fine. It'll work, and it'll do everything it needs to do."
That's awesome. Yeah, the auto graders. I remember back at Georgia Tech, the auto graders were ruthless. I was never that bold, so you get credit. But for sure, I don't think that a lot of academic institutions, when I was coming through school, this may be different now because I haven't been through through an undergrad program recently, but back then it was certainly the case was on making it work. And we did learn a lot of concepts. And again, to university's credit, it does teach you very important things like divide and conquer, some very specific problem solving skill sets that are helpful. Learning what NP hard means versus problems that you can solve in polynomial time when you're working in a code base. It is important to avoid things like in cubed complexity. Don't do 3 for loops if you can help it, especially if you're touching a database. Like, there are really good things that you learn from university that I took away. But clean code was not something I really started getting engaged with until the community of software engineers started helping me understand that it's not just about me. It's not just about the code that I write. I'm writing code for the person that comes after me. And that's an important concept, right? If you write code for you, sure, you can understand it, or maybe 10 years you come back later and you're like, I have no clue what I did. That's pretty normal, but focusing on this is about the folks that are coming behind me is a key piece to writing clean code, I would argue, because then you're not blind to the bias of, I'm the only person that's ever going to read this, so it doesn't matter.
Yeah, but sometimes the person that's coming behind you is you 6 months from now.
Yeah, that's right.
And that clean code's going to matter then.
For sure. Especially when it's something complicated and you don't have a test for it. So shame on you for not writing a test, but still. Awesome. So let's talk about the Boy Scout rule. I loved this analogy, and this is a thing that I took away from this book, and I have said repeatedly over and over again. What is the Boy Scout rule? Well, very simply, leave the campground cleaner than you found it, right? And as a consulting team, this is something that we get to try to employ all the time, because the entire life cycle of a consulting firm is you're inheriting code from, some company that didn't do the best job at producing an asset for your client, or maybe it's even internal code that is legacy, and those developers did exactly what we just said we shouldn't do, and that's just write code to make it work and move on with your life. And again, there's a place for that. Let me be very clear. Under very tight budgets and constraints, sure, especially if it's an MVP, maybe it makes sense to do that. But if you're writing production code on a production system that has a lifespan of anywhere from 2 to 5 years, I would claim that the cleanliness of that code base is paramount and 100 times more important than just getting features out the door. So the Boy Scout rule gives us this lever and this sort of heuristic that when I'm in there doing a change to a legacy system, leave the campground cleaner than you found it. But there's some very important things that have to be in place for this to be effective and even work. Jeremy, Maharshi, I want you guys to expand on that. Let's start with Maharshi. What do you think of the Boy Scout rule?
So I agree. I want to say that before I get into controversial territory here. So I agree with that. But there are instances where attempting to leave the campground cleaner will end up costing you like tons and tons of time. It will still be effective, but what if you're on a deadline? What if you have, requirements to meet? And that's usually the case with most of the clients. And so something I struggle with is trying to follow the Boy Scout rule, but getting, blocked, so to speak, by external factors like deadlines.
Yeah, and I think, that really boils down to how good's your test suite, right? Jeremy, what do you think?
I mean, I couldn't agree more about the test suite. So, if generally we're talking about refactoring when we're talking about leaving it cleaner than we found it. And if you don't have a good test suite, then you can't refactor with confidence. So, if there's no test, which is super common, then either you're going to have to write tests or you're going to have to make a risky change, and neither of those are great for a client who wants something done quickly. So it is kind of like a balancing act almost. Whenever possible, you can try to make small changes that maybe just like, oh, there's a magic number here. Let me at least put that into a constant variable. And things like that are minor. But even then, those can be risky without tests. You may not know the scope of that, and like crazy things can happen. It's it's tricky.
Yeah. I think people misunderstand what a refactor is too. And again, we're getting into some subjectivity here, but to me, a refactor is modifying the code to make something more readable without changing the functionality, right? To me, that's the definition. Otherwise, we're kind of getting into rewrite territory, right? If I'm completely blowing away an entire class and replacing it with my own mechanism, I'm not refactoring. At least I don't. There are obvious exceptions to the rule, but in my head, that's not a refactor. A refactor is something that you should be able to do fearlessly, right? Fearless refactoring. This is something we talk about internally. It's one of our core values, is we want to be able to fearlessly make changes to code to improve the readability and quality of that code without destroying the functionality. And there's two anti-patterns I see here. One is that people write tests to achieve branch coverage and not to achieve feature coverage. And there's some academics here. I actually wrote a paper about this, and it's part of my expertise from a master's degree. We won't dig into that here, but suffice it to say that research has been done to prove out that just because you have branch coverage doesn't mean you're avoiding bugs. And I can link to some of the papers and some of the research in the description so y'all can read about that and get a sense of what I'm talking about here. But if you have tests that test out features of class stacks and test out long-term branches of what a particular piece of code is designed to do from a functionality perspective and not just hit branch coverage, then your refactoring becomes a lot more fearless because your feature tests, or your test, exercises the feature and not just the branches, because sometimes you want to change branches, right? Sometimes I want to modify an if-else statement to be something like a specification pattern. I made that up, right? It's a very overly complex way of doing that, but you could do it that way. Or maybe you want to, I don't know, maybe you want to use some De Morgan's laws to kind of modify the if-else statements. All those things are important things to be able to do, and if your particular tests are not exercising that, you can't fearlessly refactor. If you can't fearlessly refactor, you can't produce clean code, therefore you can't follow the Boy Scout rule, to Maharshi's earlier point. The other thing is that your refactorings need to be of sufficiently small size in order to follow the Boy Scout rule. I have a silly saying for this. If any fans of philosophy in the room, Occam's razor, what is that? What does Occam's razor say? The simplest answer is probably the correct answer. I like to say Occam's refactor. The simplest refactor is probably the best refactor. If you're going out and making changes to swaths of code, you're not refactoring, you're rewriting. And it's important to have that distinction. Otherwise, you can't follow the Boy Scout rule. So the Boy Scout rule is not something you blindly just follow, per what Maharshi said. It is something that you have to very strategically deploy into the code base. Otherwise, you're just going to cause more problems than you're going to fix.
You could actually argue that if you have to change the tests, then it's a rewrite, not a refactor.
I love that. I agree with that actually wholeheartedly. All right, so is bad code or unclean code detrimental to business? This is the big question that I've fought my entire life, because as a business person, as a CEO, as a product owner, if it works, who cares, right? And again, no shade at these folks. They're doing their job, but a lot of times engineers are seen as just sitting around playing with toys and doing things for the sake of doing things and following philosophical memes because, that's what we do. I want to debunk that myth right now. A good developer is not following philosophical memes for no reason. A good engineer does, in fact, have the business outlook at their heart and their mind when they're writing clean code. I'd love to hear what you think, Jeremy Maharshi. Let's start with Jeremy. Is bad code detrimental to business, and how?
Yeah, absolutely. It's the fact that if you have bad code, then you don't have clean code. And as we mentioned, clean code is kind of all about readability, or very much about readability. And so when you don't have that, then you have engineers coming into the project working on it, not understanding what it does at first glance, or just taking a really long time to figure out what it does. So you're wasting time. And as we know, time is money. So you're wasting money. And then on top of that, I mean, that's just the reading part. On top of that, if they make the wrong assumption about the code, then you end up with the wrong result sometimes. So you end up building something that isn't even right. I mean, that could be. There's a lot of factors for that, which aren't necessarily the code itself. Are the requirements even right? We could get into a whole different topic there. But like, maybe controversial, but healthcare.gov, when that first came out, I don't know if anyone remembers how bad the experience was, and they had to rewrite it. And I mean, I don't know what that code looked like, but my guess is that it wasn't very clean.
100%. Yeah. Ugh. Maharshi, what do you think?
So I'm going to take what he said one step further. So he mentioned how if you're trying to work with a team and your code is bad and you accidentally make a mistake on what you're assuming, you're going to end up like snowballing. Well, what if that snowballing happens not with another engineer, but with, let's say, a product owner? They're going to misconstrue how your code is performing, and they're going to be like, oh, okay, we can just add this on top of that. And it's just going to keep piling on. And trying to get a product owner to understand, hey, my code does not work this way after that mistake has already happened is way harder. I'm firsthand experience. I'm telling you that if you can write clean code from the get-go and you can guarantee that your product owner understands at least like a general idea of what's going on, that business impact will be super minimal.
Yeah, I've run into problems when I'm talking to clients about technical debt, which is a meme these days. It's an important thing for us to understand, but I've seen so many misunderstandings of what technical debt actually is, and a lot of that comes from people just accepting mediocrity. And this is the big point that I want to make, is that mediocrity does not produce good results. It produces things that work, right? It produces maybe a product that executes and does what you expect it to do, but it doesn't produce a product that can be extended and continue to grow as your needs change. And again, I know people are going to think in terms of, well, developers just sit around and mess around and waste time. That's not what we do. What we do is to focus on building good things so that we can add to them later, but there's a trade-off there. You want to make sure you're not over-engineering things, but you also want to make sure you're not, again, under-engineering things so that we're just layering garbage on top of garbage on top of garbage, and at the end of the day, nobody knows how the product works, and it becomes the dreaded legacy system that we then have to rescue later by hiring the expensive consultants or by throwing it in the garbage and doing a rewrite and spending tons of money, when if we had just gone maybe 3 miles per hour slower and taken our time to build code that is maintainable and high quality, we would have avoided this entire problem in the first place. Which leads me to my next fun question: artificial intelligence. We've used GitHub Copilot. My whole team has licenses for it. I've gone on record talking about AI. I think it's an incredible tool. But do we think that AI can write clean code?
Yes, it can. I've seen it. But it's very dependent on the other code that's there. So if you jump into a big messy code base, then the AI is gonna write messy code right back at you.
I think that's the important thing to understand, that AI is building its brain on existing code. So this makes it 5 times more important to ensure that the code around it is quality and written well. I like to use AI to generate tests. I think it's fantastic for that. I think it's a wonderful way to keep consistency in an existing code base. But to Jeremy's point, unless you actually spend time ensuring that it is aligned to your standards, it's going to make things worse in many cases.
I'm going to play devil's advocate to what Jeremy said, and I'm going to say that it doesn't necessarily write clean code. It writes possibly good working code, but unless you know what you're looking for and you can adapt what it gave you to be good code and clean code, I don't think it'll 100% write clean code.
Yeah, fair point. All right, so let's answer the question we posed at the beginning of the show. Do we think that the Quake fast inverse square root is clean code? And I love to show new teams this because a lot of the times it just blows their mind. And we're going to throw up the example on the screen. We're actually looking at the implementation that comes off of Wikipedia. There are other implementations of this thing, but I just want to go ahead and take a look at it. So let's just do an analysis of it. Jeremy Wood, why don't you go first? Tell me what you think about this function.
Sure. I mean, right off the bat, the name of this function is suboptimal. The Q underscore R square root, like the square root part makes sense. The R and the Q, not as much. I mean, based on context, the Q probably means Quake, but like, why is it there? It doesn't really provide any additional help with understanding what this function does. So yeah, that's right off the bat.
Notice all the vowels are gone. We memed about that on a previous episode.
That's why I don't like working with C in general, because it's the standard library is old, and it was from a time where the names were limited in length, and so they had to do things like remove all the vowels. But now, where that's not a limitation, because the standard library is still the same, people just go along with that and like kind of use that as a basis for naming in C. So you still get it.
Yeah, so this is my issue with all this. So there's a random, what is that? Like a 0x5f37. All right. So just a random, like, what? There's no variable names that make sense other than 3 halves. And then there's x2. What happened to x? Did x2 eat it? I don't understand what's going on there. And it gets better. They have 2 iterations of the 3 halves that are like the calculation of y equals y times 3 halves, right? The top one and the bottom one are practically identical. So what went wrong the first time? Or the second time? I don't know. It makes no sense.
And the fun thing, if you read the Wikipedia article on this, there is some incredibly fascinating things happening in this function, right? I love this as an example. I like to give this to people to say, go read this article, because there's also a lot of context around C that you have to understand in order to be able to properly grok what this thing is doing. That magic number is from a paper, I believe, that was written in the 70s or somewhere around there, where there's a proof that basically states that this number is perfect for this particular estimation, because it's actually estimating a square root. When you're in a video game back in the day, square roots would kill you, because you're having to do some pretty serious processor nonsense to make square roots work out. Division is hard. Multiplication and addition are very easy on Silicon. Division actually is quite difficult to do quickly. And if you're basically you're computing unit vectors for lighting and things like that. So you want to be able to do that incredibly quickly to get those perpendicular unit vectors for your surfaces, for like Feng shading models and all this. And that's what this particular implementation is designed to do. So if you don't know any of that, if you've never like taken a computers graphics course and you read this, you're like, the hell is that thing doing? Like, I don't even know what that means. Could you imagine being a junior software engineer coming in and looking at this code and saying, okay, that's just magic. Especially if there's no unit tests to prove what it does. It's like, what if someone came in and changed the magic number by like 1 octet? All of a sudden the entire game crashes and people are like, what happened? So this is an example of an incredible piece of engineering work that is absolutely not clean, nowhere near clean, and could probably be cleaner because of the way modern compilers can optimize some of this code. But back in the day, they didn't have that. So they had to focus on doing a lot of this on their own. Fascinating code, fascinating conversation. Thank you, gentlemen, for your time. Hope you all enjoyed this introduction to clean code. We're going to continue down the path, and we're going to be looking at chapters 1 through 6 of this book. This is sort of the chapter 1 preliminary. This is what we're setting the stage for conversations moving forward. If you like this, like, comment, subscribe. Everybody have a great day.